Most first AI agent demos stop at a prompt and a print statement. That is enough to impress a room for 5 minutes, but not enough to build something another engineer can run, debug, or trust. A real first agent should already have boundaries. It should know what tools it may call, what arguments those tools accept, how errors return, and how results get logged. In this lesson, we are not building an AGI research project. We are building a small Python agent that can reason about a user request, use a calculator tool, query a simple database lookup tool, and return a structured answer. The important part is not the number of tools. The important part is learning the engineering shape early before demos turn into production debt. By the end, you will have a clean starter layout with folders like agents, tools, schemas, config, and tests, because structure matters even on day one. We will wire environment variables for configuration, add logging that makes runs observable, and return structured response objects instead of loose strings. We will also handle the failure paths on purpose, invalid tool inputs, missing data, and tool exceptions, so the agent fails clearly instead of failing mysteriously. If you keep one rule, keep this one. Start simple, but start with contracts. Good agent systems grow from clear interfaces, not from clever chaos. At a practical level, an agent is just a control loop. It reads a request, decides whether it can answer directly or needs a tool, executes a bounded action, observes the result, and then formats the next step. Notice what is missing from that definition: magic. The model or rule engine does not get unrestricted power. It gets a menu of allowed capabilities and a set of rules for using them. For a first Python build, that means one orchestrator object, a registry of tools, typed request and response schemas, and a small amount of memory in the current run context. That architecture gives you a path to grow later. You can swap the model, add retrieval, add approvals, or move to queues without throwing away the basic design. Start with folders that make ownership obvious. Agents holds the orchestrator, tools holds integrations, schemas defines typed inputs and outputs, config loads, environment variables, and tests protect the behavior. Inside tools, keep each capability narrow. A calculator tool should only evaluate a safe arithmetic expression. A database lookup tool should only read approved records through a parameterized query or a controlled lookup function. Inside schemas, define objects like agent request, tool call, tool result, and agent response. The point is to make every boundary explicit, both for humans and for automated tests. And in config, load values like log level, default timeout, and database path from environment variables early. Hard-coded settings feel fast in a demo and painful everywhere else. Our calculator tool is the simplest example of bounded capability. It accepts one expression, validates that the input is arithmetic only, computes the result, and returns a typed success or error payload. Our second tool is a small knowledge lookup or SQLite database reader. It accepts a narrow query like customer.id or topic.name, returns normalized fields, and never exposes raw unrestricted query power to the agent. Both tools should return the same outer shape: success flag, tool name, data payload, and error message when something goes wrong. That consistency makes orchestration much easier. Add logging around every call. You want to know which tool ran, what safe arguments were used, how long it took, and whether the result was success, empty, or failure. Now wire the loop. The agent receives a request, classifies the intent, chooses a tool when needed, executes the tool through the registry, and stores intermediate observations in a run context. For example, if the user asks, "What is 19 times 24 and what plan is customer ACME on?" the agent should use the calculator for the arithmetic part and the lookup tool for the customer part. After both tool results come back, the orchestrator merges them into one structured agent response with answer text, supporting evidence, tool trace, and any warnings worth surfacing to the caller. This is where structured responses pay off. The caller can render the answer, inspect the evidence list, or branch on warnings without scraping meaning out of a paragraph. Even in a first build, error handling matters. If a tool receives a bad expression, a missing customer ID, or a database timeout, the agent should return a controlled failure state with enough detail to debug but not enough detail to leak internals. Testing also starts immediately. Write unit tests for tool validation, orchestrator routing, empty lookup results, and the final response schema. These tests are cheap now and expensive later. Security should be boring and explicit. Read secrets from environment variables, limit the database connection to read-only behavior when possible, sanitize logs, and never let the model generate raw shell or SQL that executes directly. Observability is the final production habit. Correlation IDs, JSON logs, timing metrics, and predictable error codes make your tiny first agent feel like the beginning of a service, not just a script. So if you are building your first AI agent in Python, do not start by asking how many tools you can bolt on. Start by asking whether the boundaries are clear. A small agent with 2 safe tools, typed schemas, environment-based config, structured responses, and tests is a far better foundation than a bigger demo with no controls. That is the engineering trade-off senior teams make all the time. We do not optimize first for maximum magic. We optimize for clarity, safety, and the ability to keep shipping. If you want more practical deep tutorials on AI agents, cloud systems, Terraform, Kubernetes, and production delivery patterns, subscribe to Trust Screen Cloud and AI Engineering, and I will keep building these systems step by step.